Does everybody see it okay? Awesome. Okay, so first of all, welcome everybody, and thanks for making it all the way out here. I'm sure the drive was a little bit longer than normal, but it's been, my internet recently has been a little bit spotty. So if you run into, if I disappear because, I've got like 40 webcam streams coming in at once, I will be back within 3 to 5 minutes as soon as Spectrum and my router allow me to be back. But so today I want to talk about the future of React. And the reason that's exciting to me is just because React is a technology that I've worked with for the last 3 or 4 years, and it's been something that has changed and evolved over time. And usually I feel like I'm playing a little bit of catch up in terms of what the different features are. And so recently I've been trying to, read ahead, look at the answers in the back of the book to see what's coming up. So just a little bit about myself before we dive in. I'm an application architect at the Lead Group here in town, where we do lead generation for the financial industry. And my role as an application architect is largely building React and TypeScript applications that rely on some of the features that I'll be discussing today. And eventually we would benefit from quite a bit. And I'm thinking that most people who see these features should hopefully get a little bit excited about them and see ways that they can apply them in their own applications in the future. Before joining the Lead Group, I was a senior app dev at US Engineering downtown. And before that, I was the co-founder of a startup that focused on education software. A lot of my experience is full stack. So a lot of the features like suspense or concurrent mode would have saved me a lot of time on a lot of the projects that I've completed over the last few years. Before we dive into what React itself is, or what the future of React is, I want to talk about some of the major features that you may or may not be aware of, and some of the transitions that you may have made in your applications over the last few years. So first, when React 16 came out, one of the biggest changes that came to React was one that we didn't really even see, and that was called Fiber. They completely redid the algorithm that controls whether your DOM renders and what parts of your component have to re-render. And they had done this it was completely internal, and they did it to reduce roadblocks in developing React and kind of pay down some of the technical debt from their very early decisions before they had as fully fledged of a knowledge of what they needed in the system. Once they had that in place, they started to make some pretty big changes, like the move from really encouraging class-based components to having functional components, which are just plain old function, no properties, no lifecycle hooks, and that made the components easier to test and to reason about and even have better performance. But you've lost some of the functionality that people had spent, at that point, a couple years getting familiar with. And then most recently in React 16.8, we got hooks, which is where we are now able to take all of those features that we had lost from the class-based components and reintroduce those to the functional components. So for example, if you cared about your state, the state on your component, now you can use the use state hook, which will allow you to have your getters and setters for particular properties that your component cares about. Instead of having a tree full of context consumers and providers, then you have the use context hook, which lets you just include that as part of your component. Use effect gives you the same component did update, component did mount hooks that you might have been used to in your classes. So really all of these things we had relied on, they are back and in full form in functional components. All right, so let's dive into the reason we're all here, which is discussing looking forward. This is something that, like I said, I've been trying to be proactive about trying to see what's coming down the pipe with React, just to see, what new features I can try out, what new experiments I can run, and like what possibilities open up when the framework that I work with day to day adds features to it. Like, can I do things differently? Can I do things that weren't possible before? And really, one of the major questions as you look forward is, am I going to be rewriting a React application again in a totally new way? And that's a totally valid question when it comes to React, because there have been major changes throughout its history, from when React separated React and React DOM into separate libraries to that class and functional component based approach. Maybe you adopted TypeScript at some point. And so, you may be working on the same application, but it may have had three or four, excuse me, 3 or 4 different major iterations of using React within it. So a little bit of spoilers. I don't think that you're going to be needing to rewrite your application, because all of the same things that you're doing today with regards to data fetching and data rendering, server-side rendering, that's all going to continue to work. But I think that some of the changes that React and their team are implementing are going to allow us to provide much better user experiences. So my hope is that by the end of it, you're going to be excited about the possibility of these new features and want to rewrite some of it at least. So before we dive into the features itself, I want to discuss Facebook's goal. Both Facebook, the open source community, what their driving philosophy is behind these upcoming features. And for them, it's that apps should start fast and stay fast, regardless of the device or the network speed. Now, Facebook, obviously their concern for this is very real, because they have a huge app consuming huge amounts of data, and they have people on all sorts of devices around the world. And so that's a very Facebook scale problem. But even on something like what I do on a day-to-day basis with lead gen, you see people with all sorts of devices, all sorts of network speeds, and we are nowhere near the scale of Facebook. So this is really a goal that I think, everyday web developers share with the titans of our industry, like the Facebooks, the Googles, the Twitters. And especially in today's world, these performance issues are affecting everybody in very real ways. Just this past week, there was a little bit of a controversy where somebody had shared this page performance test about this website that shares real-time, I believe it's virus transmission data. And so we're looking for numbers under 1 here in your given state, but throughout the US, it will show you how your state is performing on how your state is transmitting the virus. Like, are you guys trending downwards or upwards? And so somebody looked up the performance for this page, and they set it to mobile, just somewhere in the US, and it came back loading, load time about 10.5 seconds. And that's after the first byte came in at about 1.5 seconds. And so the time from that first byte to the first contentful paint, this is something that I think any React developer should be caring about, like this level of performance issue. We should be doing what we can to reduce these issues so that people can get to the content they need faster. And this is really what the 2 features I want to talk about today are going to help us with. So the first of these features is called concurrent mode. And concurrent mode is basically what it says. The answer is in the name. Basically, it means that you can work on several state updates concurrently. The details become a little bit more interesting and complex as you work with it. And if you look at your experience with working on React applications and understand the component lifecycle, you can kind of start to see that your component reacts to data changes. So a state state updates, props update, and your component may or may not render, whether or not it cares about those values. But the entire thing has to render at once. And so what concurrent mode allows us to do is, under the hood, maintain different renders in memory. And then depending on what happens, based on, does that request complete successfully, or does it fail, or does it wait too long, it might render parts of that component differently based on those results. And so really where this comes down to is that it gives us a better way to handle asynchronous loading, which we probably have all built our own solutions for, but concurrent mode gives us a more reliable hook-based approach that should be provide more consistency throughout the React community. And next is suspense, which really works hand in hand with concurrent mode for the data fetching. But one thing to know about suspense is that suspense itself is not a data fetching library. All it is a way for your components to tell React that, hey, I am waiting for something. And that's it. And when it does that, it's entering what is called a suspended state. And so the suspense helper basically lets you say, if my component is suspended, then show something else. It could be a string, just like loading ... or it could be a loading component. It could be whatever you tell it to. And then when it tells React, hey, I'm ready, it will actually render the component that you have created or that you have prepared. So these changes at this point in time are really for early adopters, tinkerers, library authors that are really looking forward to trying to integrate these new features in their own libraries. And then also warriors, people who are leading teams that need to know, hey, what's coming down the pipe? How are things likely to change? But the good news for pretty much everybody on the list, on this list, is that these are currently opt-in only features. If you go to the pages in the React docs, you're going to see this big alert that says, hey, this is experimental, things are subject to change. And if you try it out, be careful if you're using it in production. But if you are prone to tinkering and you want to give it a try on your own, the docs really are amazing and are the source of a lot of the content for this talk. But you can actually opt in by just changing 1 or 2 lines in your application. So if you've set up React before, this should look very familiar. React DOM.render, and then pass in your root component and choose the element that you want to attach it to. And this changes only just a little bit to get into concurrent mode. So React DOM.create root instead of .render. And then you pass in the element, and then at the end, you render the app. One thing that React mentions is that if you want to start trying out concurrent mode, they recommend that you are strict mode compliant. So because it is experimental, they want to make sure that the core of what you're working on is more stable. Okay, so let's start to understand concurrent mode a little bit better and what type of problems it's trying to solve for us.
I'm sorry, could you back up 1 slide, please, for just a moment?
Sure.
Thank you.
Yep, sure. Okay, so let's go ahead and talk about the problems that concurrent mode is trying to help us solve. One of the most important ones comes in this form of user experience. If you have worked with trying to handle showing your user how your application is loading information, you may have noticed before that, okay, I'm going to navigate to a new page, but then I'm going to show them a loading indicator. And then, after some indeterminate amount of time, it's going to load again. Or maybe it won't, maybe it'll fail somehow. But the intermediate state feels like, okay, I've moved forward only so that I can take a step back. And so this is really something that concurrent mode can help us with, where it will move forward, render part of your new UI, and then as necessary, load different portions of the new UI so that your user can continually feel like they are beginning to move forward. And then in the event that something does not load correctly, it gives you a way to fail predictably and in a way, or if things start to take longer, it gives you the tools to inform your user that this is happening. With the technical problems, imagine that you are working in a team without version control. So your application has to render and it has to look for all of the changes at once. If you are working in a team without version control, but you don't want somebody else's changes to interrupt yours, you kind of have to tell them, hey, wait, like, don't touch these files until I've got them in production. But if you have version control, you can have everybody work on their own branch, make their changes, and then merge them in eventually. So this is the same type of idea that's happening with concurrent mode, where if you have told React that, hey, this is a transition that I care about, it's going to be rendering both versions of the changes in memory so that, when you're ready to make the switch and you have the ability to tell React at what point to do that, when and how to merge those. So that takes the that version control free zone. That is more akin to the current model where rendering is blocking. Like if you render a component, everything inside of that component is blocked until it's completely rendered. You can't interrupt that process. But with concurrent mode, what you can do is you can, because you have both versions in memory, it is possible for those to be swapped even while one is in the middle of rendering. You can say like, oh, you were rendering the loading version while I finished the other one and I can swap it in. This is very abstract until you start to work with it. But one of the examples that I was found while kind of exploring this in one of the mental models that really helped me figure out like, okay, what's happening here? It came from the world of video games versus web. So if you've played games on your computer online, especially if you have done so for 5, 10, 15 years, you may have seen some sort of sync issue on your monitor where just because of some sort of display issue or network issue, you will notice that the top half of your screen looks a little bit different than the bottom half of your screen. And this is because the part of your system that is your video driver that's rendering this has gotten ahead of the part that's creating these pixels, deciding which pixels need to be rendered. So they get out of sync. Like for example, if you were rendering an emoji and you were putting the pixels there dot by dot, it takes a certain amount of time for your CPU to calculate here are where the pixel should be. But your video card may be faster than your CPU. So as it renders, you may see a third of the emoji, half of the emoji, and then the full one. And this is what becomes tearing. Like that's the break that you see here. In our applications, it can kind of happen in the same way where we load a page, but we need different parts of our application. So maybe I need the user profile at the top of the page, and then I need a blog post or a comment from that specific user, and then a list of responses or additional comments for it. I might load each of those things separately, but because of maybe the request speed was faster on one of them, or maybe the server responded more quickly to the other, you can see things out of order. And so this tearing becomes a user experience issue as well as a technical one for us. Concurrent mode kind of gives us the answer to this problem. So this is one of the diagrams from the docs where we enter a pending state, and then once we are in the middle of loading it, we enter that area of the UI where I mentioned a skeleton. This is something where the UI is ready and different pieces of the UI are loading. And then once it reaches done, all of the content displays. The reseated step here, this is when you begin to move forward to a whole page, but instead of just showing portions of the page, you show a loading screen for the whole page itself. So you've moved forward and then you have to wait some more. Whereas this pending and skeleton states give us the ability to move forward and display information incrementally until it is fully complete. One of the examples they've referenced pretty frequently is imagine that you are filtering a list. Like you have a list of products and you have a search field, and you need to be able to drill down into that. Like say I want to find a new pair of shoes to go walking with during the quarantine. If I search for Skechers and I type in SKE, you're going to see that list filtered down, but it's going to feel a little laggy as you are typing. And this is because every time you type, it's sending a request. It may be re-rendering as soon as it gets the response. And so as a user, it can feel a little bit wonky. Normally, we kind of solve this by adding debouncing. So saying like, if somebody has paused for 300 milliseconds, or if somebody has left the input, then fire the request and show the results. With concurrent mode, what happens is that it sends the request, it fetches everything in the background, and then as soon as it has the fully rendered new version of the component, it then swaps them in, which is kind of what was happening with the video game image. So how they solved that was to render the new frame and then load it when it was ready, rather than syncing each individual row at a time. All right, so this has all been a little bit abstract so far. So let's go ahead and look at a little bit of the concrete implementation so that you guys can see some of the code and how it might affect some of your components in the future. If you want me to pause a little bit longer here so that you can screenshot or anything like that, just let me know. Okay, so this example is straight from the docs. So if you are curious about this, I would recommend going to the React docs and looking in their concurrent mode pieces, particularly the concurrent UI patterns, because that's a treasure trove of information here. And this is a little bit of a pared down example, but it gives us enough to talk through. So first, I'm going to set state. So this is one of the hooks in React. Basically, I'm just saying I want to be able to remember something, a piece of data, and use it within my component here. This one should be hopefully familiar if you've used React hooks so far. The new ones are use transition, which gives you back two pieces of information, start transition and is pending. Start transition is what's responsible for letting React know that, hey, I'm going to be changing something, so you need to track multiple states here. And then is pending is React's way of telling your component, hey, this has or hasn't finished yet. And then you'll notice the timeout milliseconds argument, which is a way of saying, React, just in case this takes too long, I still want to be able to respond in the UI to that. And so that is pending field is pretty simple. Like you can use it to do anything from, hiding or showing a component, enabling or disabling a button. It's just another piece of information that you can use within rendering your component. But really the meaty part of this is start transition. So this is the on-click handler for this button. And inside of it, I am just saying start transition, which tells React, hey, I'm making a change. And then I'm going to start triggering these asynchronous calls. And as soon as it's done, I'm able to set resource with the result of this generic fetch profile data request. Inside of the, I can give some sort of loading status inside of this component. Normally you might have the bar that goes across the top of your screen to say something is loading. Here you can have a spinner, and right here I just have the loading ... But one of the most interesting parts is what happens to the component that is dependent on this data during this time. So let me back up a few steps so you can see everything as a whole. Throughout this, our goal is just to say, React, while data is fetching, I need you to show something is loading. But the profile page actually cares about the data that is coming back from this endpoint. And so this is where suspense really comes in and helps us out. So suspense, like I said before, it is a way for your components to tell React that you are waiting for something, or that it depends on something that may be asynchronous. So that can be an API call, that can be actually loading a component. But at the core, it's all about controlling the transitions between the data that you're loading and that loading state and the final result that you're looking for. In my mind, this is more about solving the dev problems that we run into rather than only the UX problems that we've talked about so far. If you've worked on different teams that have used React in different ways, you may have handled asynchronous requests in as many teams as you've been on. So in my own experience, I've used Redux Thunk, Redux Observable, just the fetch API within my components. And so those are three different ways to solve pretty much the same problem depending on the scale of your app. And this inconsistency leads to extra dev work and extra onboarding time in my experience. And there's also technical problems associated with this, because normally, especially with something like Redux Thunk, you need some way to make sure that to keep checking if the result has come in, to cancel it if you have, or to cancel your waiting on that result if you have already gotten another response that kind of supersedes that. If somebody clicks on a button and sends 5 requests at a time and you only care about the first or the last result, you need a way to handle that. So handling these race conditions and kind of keeping track of the state of those requests is something that suspense can help you with. In the old paradigms of fetching data, you can really, it's pretty consistently that you start fetching data, you finish fetching data, and then you begin rendering. And that should be pretty familiar given if you've worked with any async code in your components. And this can be at a component level or a page level. And so if your component is, if you have like 3 or 4 components that all depend on different endpoints, you as a developer have a little bit of a responsibility to figure out, how are you going to load that data? Am I going to decide I'm going to just wait until all of it's ready? Or am I going to load the page and then hit those requests one by one? The issues that you run into is that if you wait for all of them, your app is going to feel slow for your user. If you render them one by one, you can run into ordering issues where maybe I see the comments before the blog post, or I'm going to see a waterfall if I only fire the comment request after the post is loaded. What suspense gives you is the ability to render as we fetch the information. And our workflow with suspense looks a little bit more like this, where we start fetching, and immediately start rendering. We're not waiting on anything before we render the application. Then once we finish fetching is when we can finish rendering. Before suspense, you had to set data at the right time, but with suspense, you can set state immediately and then begin, which allows you to bypass the issue of getting data in weird states. And the suspense component allows you to draw boundaries around what pieces of your application load or render together. The way that this works is actually pretty interesting under the hood, is that this is a very pared down example of what they call it a suspender. It's what you tell React to say like, hey, I'm still waiting on something. But basically you have a value of has something resolved? And if it has, then you just return the value. But if it hasn't, you throw a promise. So this is similar to throwing an error. This is something I had never thought about before digging under the hood of suspense. But you throw a promise, and just like error boundaries in React, suspense reacts as kind of a loading boundary to say, hey, I'm still waiting on something. And receiving that promise allows it to keep returning to whatever your async method is, and then actually return it when it's ready. Okay, so let's look at an actual React suspense example. This is a little bit smaller than the concurrent mode, and we're going to pull it all together after this. But the general principle is that you have a suspense component that wraps the component that depends on information. So before we even create our component, we actually want to create the resource that the component depends on. So this can be any sort of potentially async activity. And what you might notice is that this resource is actually outside of our component itself. This allows like when you call app or when you call posts, imagine we had another request inside of posts, the request can fire immediately. So you're not waiting until any mount, any rendering to happen. You're pulling the data fetching out of the component rendering process. And that's kind of at the core of what concurrent mode and suspense allows you to do. It looks and feels a little bit weird at first, but as soon as you start to see it work together, it becomes a little bit more intuitive and natural. So in order to tell React that something needs to wait on something else, you just wrap it in the suspense component. You can provide a fallback, can be a component, can be just text, can be an image, anything that you really want, like as long as it's a valid return value for a functional component, it can live here in the fallback. And then with post resources, this gives us the ability to say, here's the component that depends on this asynchronous piece. As soon as post has loaded lazily, and as soon as the resource is available, it will swap in from memory the full post component already rendered for you. Okay, so let's look at all of it together, both concurrent mode and suspense. So the example that we're going to walk through here is a profile page. And again, this is straight from the docs. So what I would recommend is, after this is if you're interested in concurrent mode, is go check out the concurrent mode docs, because they have step-by-step different code sandboxes that let you really dig in and see the different steps and values that each of these layers provide. So we're going to set up this component just by adding the use transition hook, like we did in the first example, where we get the callback for start transition and whether or not this is pending. And we're going to set a longer timeout here of 10 seconds just to say, hey, we're going to give this profile page 10 seconds to fully load. And then set resource. This is the async, potentially async resource that we referred to earlier. We're going to create a callback for our click, for a button click, where we are going to pass through the start transition. And then we're going to pass through the asynchronous fetch profile data. So that when somebody clicks, we're going to start fetching the data, and we're going to pass that suspender to the component that cares about it. We're going to wrap everything inside of suspense so that as things are loading and happening, it can show that loading information, and then pass the component that cares about the resource the value that comes through, and set up a button that allows us to pass through that callback. And we're going to also disable it based on the pending. So Doesn't matter how many times somebody clicks this, it's only going to happen once until it is done. And then one of the other pieces that is pretty exciting to me about Suspense is that you can nest these. This is something that you can include, like if I'm building a page that has multiple dependent pieces, by layering them in these different Suspense blocks, I can control the loading sequence very, very clearly. So profile timeline may or may not rely on a different set of resources. And so just depending on what I pass through to this resource parameter, it gives me the ability to very clearly sequence those dependent requests and really control the loading of my application very intentionally. Look at it one more time here. And hopefully one thing that is apparent is that even if I didn't have Suspense and concurrent mode enabled in this profile page, the component would not be that much smaller if I was doing it. It might, in fact, be larger if I was depending on any external integrations with React, maybe with some GraphQL. Like this only adds on average, from what I was playing with in these demos, maybe 7 to 10 lines of code to your component. So really stepping in and adding these kind of async and loading controls and boundaries really doesn't blow up the size of your application too much. Because this is experimental and something that you can add in, it becomes something that you can hopefully iterate in your applications with, instead of really feeling like you have to move your entire application over to concurrent mode all at once. So a couple of caveats with concurrent mode and Suspense as a whole is that everything in the concurrent mode and Suspense portions of React are still highly experimental. They're getting a little bit more consistent with the API, but anything you build with it today may be subject to change. So you may want to lock your API into a specific version and then play with it there. You also want to make sure that you're loading your resources intentionally. Like this, this example is very simple, but if you have a data-heavy app, the purpose of concurrent mode and Suspense is to really help you control the user experience and get back to the point where you can say, I'm going to load the information the user cares about in the order that they most care about it. So really think about the user experience first. You don't have to always wait for all of the data to come through, but you also don't have to load everything, every single item as soon as it's ready. And like the first example that comes to mind for me is if I have a long comment list on a post, I don't need to re-render every single time that a new comment comes through if I'm using some sort of GraphQL or one request per comment to get it. I can load them as soon as the list as a whole comes through. So just be very intentional and deliberate as you design that user experience. The ecosystems around React Suspense and concurrent mode are still in progress because it is highly experimental. So there is some pretty good GraphQL support with Relay and React Apollo hooks. Lazy loading works really well with React.lazy, but isn't there for everybody yet. Suspense is working inside of React Native. And with server-side rendering, it's not quite there yet. There are some experimental smaller libraries that have maybe 1 to 200 stars on GitHub, but nothing that is in Next.js yet, but they are working on it currently as the API becomes more stable. And if you see a lot of these changes coming and you're a little bit concerned about moving these into your application and the effort that that might take, I would say don't worry about it yet because they are experimental. And all of the effort that Facebook has been putting into this has been very slow, very deliberate. They had been working on these features since 2016, 2017 when React 16 came out. And they haven't been working on it alone. They've been working with the team at Google that's behind Chrome. They've been working with application or libraries like Next.js. And they're pulling from all of these teams and really being as collaborative and open source as possible in their effort. Does anybody have any questions? Let me finally open up the chat. I've lost the Zoom. Okay, sorry, I could not share my screen while I had that up, so. Okay, to Joe, I've seen integrations with both. The question is, Suspense is not intended for APIs and we should use Relay instead. And do I think the docs are underselling suspense? Based on what I saw, like I played with a fetch suspense library that worked just fine with React or with REST APIs and suspense. I think that Relay currently is the most deeply integrated piece with suspense, just because Facebook is actually using it on their new integration with like the new version of Facebook. And so those have the best examples so far and are pretty deep. And but I don't think there are any barriers to using suspense with a REST API, because the only thing that it's there to do is to say, I'm waiting on something. And it's just hooking into the core of React to let it know that. And Max had asked, do you know anything about how these new features impact memory/CPU usage? I do not know. I have not done profiling with this yet, but if anybody else has experience with that, I'd love to hear. Yeah. Does anybody want to use their mic instead of the chat for a question?
I guess, sorry, can you guys hear me?
Yep.
Great. So I know that one of the points you made was, of course, loading intentionally. It's usually better for if it takes a slight second to load everything together holistically, it's better than to suddenly have everything popping in like machine gun fire on a page. Mm-hmm. So when it comes to, you know, the kind of high-end performance you can get with concurrency and suspense, mm-hmm. to where you can get things pre-rendered before you have the full information, what do you think are the good use cases for that for an application? Like what kind of application would that be mm-hmm. beneficial for a user to have that kind of rendering, as opposed to our typical, just like Facebook's consumer-facing apps that are more about a comforting overall aesthetic and experience?
Yeah, I love that question as an architect, because in my day job, it's always, it depends. And so mm-hmm. The first thing that comes to mind for me is that if you're just building like a front-end site that is very user-facing and is something that you could build with WordPress and it's very content-driven, you probably don't need suspense and concurrent mode at all, because that's not really the use case. Facebook is probably the extreme end of a data-driven application that's, you know, providing lots of different requests in different areas of their UI. But I think that anybody that's building an application that is pretty heavily data-driven, so maybe an admin dashboard could be a good example with lots of different widgets and stuff like that. I think those are good candidates for really benefiting from loading portions of your UI before the data is fully ready, or before the data for the whole page is ready. So that's the use case I have in mind, but I'm sure there are many other like examples that fit the model.
It could be like some kind of reporting dashboard to show the most mm-hmm. up-to-date numbers, just all coming in at once.
Mm-hmm. And the concurrent mode lets you re-render portions of the components. Like, so if you have a whole page and it's got those 8 different widgets, for the reporting, you know, as the data finishes for one of them, it can replace just that one without having to re-render the whole piece. And so really having interruptible rendering rather than blocking rendering, that's the terminology you're going to find in the docs if you dig into it, gives you the capability of replacing those pieces as you need to and as it's ready.
Yeah, I just had a thought that probably trying to make a web platform for trading software, that would be one of the best use cases.
Yeah, that can be very good. Andy, I think I see you unmuted. Oh, no questions. I thought you were queuing up. Okay. Anybody else have a question about concurrent mode, suspense?